Hello, happy people. This is Mr. Wilcox coming to you from my kitchen table again. This will be our first video lesson for week 3. Hopefully you all found your packets on Brightspace. Today we're going to be talking about exponential growth. So far in the chapter we've talked about properties of logs and logarithmic equations. The applications for this comes in exponential growth and decay. And so we're going to start with growth and talk about compound interest with growth, and then we will talk about decay. So that's the plan basically for the next 2 weeks. So exponential growth. Here is the formula for exponential growth. I'm going to pause now so you can pause the video and write this all down. So just like lines have generic equations like y equals mx plus b in slope-intercept form, exponential equations also have a generic form, which is y equals ab to the x, or since we're going to be talking about time here, it's going to be y equals ab to the t. And what's going to differ between growth and decay is whether we add our growth rate or subtract it. So since we're starting with growth, we're going to add our rate. And remember, a rate is a percent, and we're going to have to write that as a decimal. So in the end, the equation we're going to be using is y equals a times 1 plus r to the t. So that's what we're going to be using for growth. So here's the example we're going to be doing. Again, I'm going to pause here so you can write this example down by pausing the video. And then once you've written it down in your notebook, hit the play button and we'll go through it. All right, so all of your examples and all your questions are going to be to write an equation and then use that equation to figure some stuff out. So the example said you invest $1,000 into a stock in 2005 and it grew at a rate of 6% per year, and we have to write an equation that models that. And remember, the equation that we are using is y equals a times 1 plus r to the t. And I know it says the 5 years thing, but we're going to ignore that for our first bullet, which said to write our equation. So A, remember, is our initial investment. So A here would be our 1,000. And it said it grew at a growth rate of 6%. So if I turn that into a decimal, that is 0.06. Oops. All right. And then for our first part, then we're going to write an equation. So for the first part, we're going to leave the t alone. So we're just going to plug in our a and our r. So we're going to get y equals 1,000 times 1 plus 0.06 to the t, making our equation y equals 1,000 times 1.06 to the t. So that is the equation we're going to use. And then we are going to use that 5 years here in just a second to solve our second bullet. All right, our second bullet said to use that equation to find the value of the stock in 2010. And so remember, it already gave you the 5 years, but if it didn't, we take our 2010 minus 2005 to find out that that was 5 years. So the equation we just came up with was y equals 1,000 times 1.06 to the t. So we're going to use that equation now by replacing our t with 5. So if we put that equation as we see it into a calculator, parentheses and all, we'll get an answer of 1,338.23. And I went to 2 decimal places because this is money in this example. So our answer in the end is $1,338.23. So that's what we are going to be doing with growth. We're going to be writing an equation. Remember to keep the t in there for your equation. So the top part here, this would be your answer to write an equation. And then we're going to use information in the problem on time to actually solve something, and you may have to use a log to actually solve for t. So hopefully this helps. I hope that you are happy. I hope that you're healthy, and I hope you all have a great day.